right, welcome, welcome, welcome. So this is the Einstein Prediction Builder and Einstein Discovery Implementation Best Practices session. My name is Dervish. I'm a solution engineer on the Einstein team. And with me?
And I'm Thierry Donogo-Lancer. I'm a director of product for Salesforce Einstein.
Right on. So thanks for taking some time with us. So in the next 20 minutes, we're going to cover a lot of ground, and we're going to just start right here.
Yeah. So I'm sure most of you are familiar with Einstein now, but just as a recap, Einstein is your smart CRM assistant. It's AI for CRM. It's going to help you discover insights hidden in your data. It will help you predict outcomes for your business, for every function and industry. It will recommend you the next best action you can take or offer, and you'll be able to automate business procedures over time. And we cover the whole spectrum here, from the more descriptive side of what happened and why, to the predictive and prescriptive of what can you do about it.
Now, my last session that I just did an hour or so ago up on third floor was about how to use Einstein Prediction Builder and Einstein Discovery sort of as complementary tools when your goal is to have predictions delivered to the user in Salesforce, right? So we have these products, Prediction Builder and Discovery. Prediction Builder is really good for someone like a Salesforce admin who just wants to get a prediction on a record, say a contact record or a case, and they want to do it really quickly, and you already have the data in Salesforce, and you want to use machine learning to build a prediction, but you don't want to deal with any of the details. You just want to click, 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 and have a prediction. Prediction Builder is great for that. When you need to go a little more deeper, or you need to do a little more diagnostic, or perhaps you want to do prescriptive analytics and actually give the users guidance on, like, if you do this, you can correct the situation, that kind of thing, specific guidance, then Einstein Discovery might be a good fit. So we're going to kind of talk about both of these products in general terms in this session for best practices, because at the heart of them, they are both machine learning platforms. Okay?
So we only have, unfortunately, 20 minutes with you, so it's going to be pretty short. So we won't be able to cover everything, but we're happy to stick around after the session if you have more questions. But today we want to start by asking, how do we even start identifying which AI problem you should solve? And then explain a little bit why machine learning projects are different from your typical dev projects. What are some things you should think about before you even start? And then we'll talk about picking the right tool for the job. Yeah, Einstein offers many tools that you can choose from, so which one you can use depending on your use case. We'll talk a lot about data, because data is really the key, of course, to machine learning projects. We definitely want to talk about that. Integration is key as well. Once you have those predictions, how you integrate them into your business process to be effective. And then we'll kind of talk about the beginning of this AI journey. So to get started, Darvish, can you tell us a bit more about how do you get even started on these AI projects?
Yes. So great question. When you're thinking about Einstein to do predictions within Salesforce, and you want to just sort of like figure out how do I start, because there's so much details you can get caught up in, I always advise customers just to go back to the basic idea that these products are really focused on one specific business outcome that you care about, right? So focus on what your sales leaders, your CEO, whoever it is, if they went and we're going to put a prediction into Salesforce, what would they pick, right? So things like, how do I maximize my win rate for my opportunities? How do I minimize the time to close? How do I maximize customer satisfaction scores, right? It's very specific, very focused on one business outcome. And if you approach it that way, maybe you have 5 or 10 of those, but at least if you can just pick the top 2 or 3 to get started, then you can start to apply Prediction Builder or Einstein Discovery to that problem and make some progress very rapidly. So I always encourage you to start there with the end in mind, right? What is the KPI that you care about? So that's number 1. Whoops, sorry. Number 2 is, Thierry, why, when we're thinking about this kind of stuff, why are machine learning projects different than other things our customers might have done before?
Yep. So you'll see very quickly that machine learning projects are quite different from your typical dev projects. First of all, it's very important to identify if your AI problem you have in mind falls into the easy category or the harder categories. There's a broad spectrum of things you can do with AI. Some of them are pretty well-known issues. Like, for example, you want to detect fraud, or you want to score your leads. These are the easier type of AI problems you can tackle. There's much harder problems. Once you want to maybe give real-time feedback to your service agents while they're on the call, that necessitates NLP, advanced NLP, natural language processing techniques. So it's very important to understand whether it falls into the easy or hard category, because you may need different people on your team. You may need researchers or more like engineers to tackle these problems. Then the other thing to know is you may not know ahead of time whether it's going to work, basically. It's very different from traditional programming. You have this drawing on the top right. You basically define the program, you have your inputs, and you get your results, and then you're done. But machine learning, sometimes you don't know if it's going to work ahead of time. You have this desired outcome in mind, but really the result of all this is this program then is going to feed on itself, right? So there's this iteration problem. So you have to maybe start, with a proof of concept. You have to maybe do hackathons, be creative about how you, start on this process, and make sure that humans are in the loop. Because usually when you start, you may not have all the data you need. You start with a lot of heuristics, baseline, and it's important to have humans who continuously give you feedback on what you're doing, and also for to accumulate the data that you need to learn and eventually be able to predict, right? And then there's a lot you can do with AI, but where do you start? It's very important to identify this bite-sized portion that you can actually start with. Don't reach for the moon just yet. Have the moon, in the back of your mind, but what is this first initial little bit that you can do to get started on this journey? So Darvish, tell us a bit more about the different tools that we could use to get started.
Yeah, so one of the most interesting things that happens when I'm working in one of the Einstein booths is a customer will come up to me and say, so tell me about Einstein. What is this Einstein thing, right? And so it's important to understand that Einstein is an umbrella branding for lots of interesting technologies underneath that run the spectrum of descriptive analytics with Einstein analytics through predictions and prescriptive analytics, et cetera, right? So when you're trying to tackle one of these challenges, you have to ask yourself, am I really asking the question of like what happened? Am I looking at historical data, just sort of a dashboard kind of a scenario? Or are you looking for more predicting what's going to happen in the future? Do you want to provide prescriptive analytics to your users on specific things that they can go do, right? So when they're on the phone with the customer, the guidance might say, put them on a marketing campaign or whatever it is in your world. So definitely think about trying to peel back a layer or two and figure out what the right tool for the job is. And when you look at the Einstein spectrum of products and technologies we have now, we have something for all of these categories, right? So you just have to kind of do the matching up of the product to the business problem. And so now, Thierry, talk to me about, if we're going to do prediction builder or we're going to do discovery, data drives everything, right?
Yep.
So why do I care about data for machine learning?
Data drives everything, so we definitely want to spend a bit of time there. So first of all, like 80% or more of your time is going to be spent on just getting the data, and this kind of a diagram from our friends at Google illustrates this well. Like when people think machine learning, they think all the algorithms, I'm going to run my random forest, my logistic regression, but this is a tiny part of your machine learning project. This is this little black box in the middle. Everything else in this very complex infrastructure that you'll need to actually get this data into the right place. In fact, I just had a meeting with a customer like right before, and we're talking about this. What is the data that we need for this prediction? How do we aggregate it? How can we get it so that we can actually even start, right? And then another thing that is key is you need to actually know your data. It seems simple, but a lot of companies, you don't really know your data in the details required to do machine learning, which means you actually need to do BI before AI, right? Like, for example, that's from a customer scenario where we were trying to predict, this zero class, basically that big blue bar on the left. But as you can see, we have many examples of when it's not happening, but we don't have example of when it is happening. And what we want to predict is when it is happening. So we have a problem here, right? So it's very key to create your dashboards, analyze your data, do your typical business analytics before you even start trying to predict anything. Then setting up predictions actually can be tricky. You have to define what you want to do, very carefully. Some cases are easy. So in the data science jargon, we have this concept of a training set that you learn from, and the scoring set is what you're trying to predict on, right? So some cases easy. Let's say you want to predict, for example, the graduation year at your college, right? Then you're going to use all the students that have graduated before, let's say 2018, as historical data to learn from, and then you're going to predict on those that are currently in college. Pretty simple. Another typical use case, you want to predict the price of a house. Again, you have many examples from the past that houses that sold for different prices, you use that to learn. And then for the current houses that are up for sale, that's what you're going to predict. But let's say, for example, you want to predict churn. This is already more complex. How do you define churn? You have all these companies. You want to know which ones are going to churn or not. But what is the training set? What is the scoring set? So here you have to be a little creative about how you define it, and that be different based on your business. So an example could be, the accounts that have not purchased anything in the past 6 months, you consider them that they have churn. That's your definition of it. Those that have not churned are those that have purchased something in the last 3 months. And then you want to predict for those in the middle, those that have not purchased anything in the past 3 months, but have purchased anything, previously. And this is something you may want to iterate on, you may want to start. It's going to depend on your sales cycle, on your objective, but it's very important to ask the right question at this stage. And then there's lots of potential issues to deal with. That's not going to be fun, but I have to talk to you about it. Unfortunately, data is messy, data is dirty. You know the traditional adage of garbage in, garbage out. So when you start looking at your data deeply, what you will see? You will see you have missing values, you know. Many records won't have some of the data because of the process, because somebody was lazy about entering it, because maybe things changed, so you don't have that data. You have data drift. Well, the data will actually change. So you will learn from some data, but then over time it will have changed, so you won't be able to use it as much. Also, field usage change. You know, maybe because of processes change in your business, you used to use that field for a certain reason, and then it's used now for something else. You could also have bias data. That's very common, you know, because of the processes, because it was based on human-defined rules. There's inherent bias in the data, and if you learn from that, what are you going to do? You're going to just repeat that bias over and over again, right? Which is a big problem. You could also have unbalanced data. This is very common because oftentimes companies want to predict something that doesn't happen very often, right? So by definition, you'll have a lot of examples of, you know, what you don't care about and very few examples of what you care to predict. So there's techniques to take care of that. Volume is an issue sometimes, but typically, if you have a lot of volume, that's where data is useful. That's where predictive is useful. If you have little volume anyway, you won't be able to do much, and you probably don't really need machine learning. And one of my favorite ones is the label leakage problem, which is a little similar to Marty McFly in Back to the Future, like going to the future and finding some very cool information about who is going to win the next set of games, and then going back in the past and using that information. And the example I always give is in case you want to predict, for example, which of your leads are going to convert, right? Oftentimes, your lead comes in your business, you know, some information is filled in by your customer on a form, on a web page, and then pretty much nothing happens, you know. There's very little that's updated, and then right at the moment where you close the lead, you do some changes. You add like the amount of the lead, like the amount of money you made, or you pass on the information of who is going to take care of it. The problem is when you train your model, you have access to this data. And if you create your model based on this, the model will be, well, it's simple. You know, if there's an amount, then it's going to convert. And if there's not, it won't. The problem is when you actually care about the prediction, which is early on, you won't have access to this data, right? So it's like information that you should not have. Basically, we call that hindsight bias also. This information you should not have that you use, and it's completely useless for your model. This is just a sample. There's a lot of potential data problems. I just wanted to highlight a few that you should think about when you start on your journey. So back to you, Darvish. Tell us about now, how do we integrate all these cool predictions into our tools?
Right on. All right, thank you, Terry. So if you think back to the first slide that I was talking about where I said focus on a specific outcome to get started, right? So imagine that you are going to put something in front of a service agent and you want to predict a customer satisfaction score. So the real value of Einstein, both prediction builder and discovery, is to start with the end in mind of putting, you'll notice the component I have here with the arrows pointing at, where the data, the insights, the intelligence is delivered in a component to the end user, right? That's really where the money is made, is when your salespeople, your marketing people, your service people are directly interacting with your customers and prospects. That's what just like starting with the KPI or the business outcome in mind, start with a visual like this when you're trying to explain to people what you're actually doing. They'll get it, right? Because you're going to put a number up there that's something you care about, whether it's maximizing sales or CSAT or whatever it is in your world. So I always encourage customers, let's start here, and then we'll work backwards through all of the data things and all of the other details, right? So put the AI, the insights at the layer of engagement in Salesforce, whatever that is in your world, right? Sales, marketing, whatever. So start with the end in mind. That's my advice there.
Yeah. So a few things that we wanted to leave you with to think about also is basically AI is going to be a journey for your company. It's not something that you put in place and then you're done. It's going to completely transform your business. It's going to last for basically many, many years. So a few things to think about. First, make sure you have set the right KPIs. How are we going to measure success? It's going to be new. You're going to have resistance, maybe from management. They want to make sure that this new AI thing is actually providing value. So traditionally, for data science projects, the metrics, the KPIs that were used have been kind of data science metrics. What is the precision I'm getting? Am I getting the right precision on my leads? People often ask me, how do I know it's working? And actually, I would say it's more important to have business metrics, business KPIs, right? Something that you can tangibly measure. So it could be like a money amount, for example, like am I closing just more business since I've been using this thing? It could be just measuring like how many, for example, service cases your agents can tackle in a day, how many times does it bounce around back and forth. So basically have concrete business outcomes, something that you can measure, that you can put a number on, right? You can come back to your management a few months later and say, hey, look, like we closed 20% more deals or whatever it is. Then the other thing is, can you actually productionize it? That's a big thing, because oftentimes, there's been this in the past this disastrous POCs that were made because it was seen as more of a research project. So you create this very complex algorithm. You make your TensorFlow model or your Python and everything, and it takes like 3 days to compute. And then you realize, well, actually, I need my recommendation like real time, right? So if this thing makes 3 days to compute, it doesn't work. And actually, an example of this that I've seen recently is, Netflix runs a competition yearly to find like the best algorithm to recommend movies, right? And for many times they were measuring, like the most accurate. They have their own like business data science metrics to see, we could measure the accuracy of these movies by seeing what people watch. But the last time, actually, they didn't pick the best model because the best model was just such a huge machine that it was impractical to run, And so think about this, like what actually can you put in production? What are people going to be able to use? Also, validation will take time. I'm sorry to say, but you will put your system in place. You won't know for months whether it's working. Because, for example, let's say you want to score your leads. If your sales cycle is 6 months, then you won't know for at least 6 months whether it's working or not, right? So how can you make sure you're actually directionally correct? How do you can have these checkpoints over time to know that you're going the right way, or you need to like switch a little bit? The other thing is, again, models are living things. They live, they breathe data, and they give you results. So you can't just put them and kind of abandon them, right? And so, for example, that's why Einstein Prediction Builder is very good, because every month, automatically on a schedule, is going to retrain and give you updates, right? But you'll have to think also, like, what have changed in my business? Do I have more data that I can use to run my predictions? And you want to incorporate that, right? So don't forget your model in this corner. Like, make sure you actually think and take care of it. And then soon enough, you'll realize, like, you have tons of things you can do with AI. Oftentimes when I meet customers, they tell me, "Oh, I don't really know where to start. Like, do you have any advice?" Like, lack of ideas. But then, like, once they put the first prediction in place, suddenly they have like 20 ideas they can do, right? So once you realize what's possible, there's a lot to do. So start with like a simple thing you can start with, as I said earlier. But then the universe will expand, and you'll have a lot more to do. And then you just have to accept that your business is going to change. This is not a minor little new tool, productivity tool. This is going to be a game changer if it's done the right way. And done the right way means change management. Basically, the way people work will change. Some of the tasks that people spend a lot of time on are, in any job, is oftentimes repetitive, boring tasks. This is what AI is good at automating down the line, right? And so it means that people will be able to shift and spend more time on other things, spending more time with customers on the phone, or being more creative, hopefully. And so it's really important to make sure you have this discussion from the start, but definitely it's going to be an iterative process of thinking, okay, now your job has changed. What are the new ways we're going to evaluate your performance? How do we incorporate these new predictions into the flow of our prediction? So AI is a journey. This is just the beginning. So that's what we had for you today. Thank you very much for coming. Again, we're going to stick around if you have questions for a bit. Don't forget, you can go to the 3rd floor if you want to see more about Einstein, see some cool demos, Einstein Ridge, and please review our session if you liked it. Thank you very much.
Thank you, guys.